Good morning, dear primary 6 students of St. Joseph's International School. In this video, we continue our series of videos explaining primary 6 science curriculum, and in the last few videos we have been talking about systems. We started with the cell as a system, and we moved up to the body as a system, the whole body, and now we are talking about energy as a system. We already know what a system is, so let's see some different kinds of energy. When I say energy, one of the very first things to come to your mind is electricity, right? And food, of course. But this time we're talking more about electricity. So, when you look around you, everywhere you are, anywhere you are, you find electricity. So here, you find electrical devices everywhere. So behind the wall, if you ever see that, you can always find many wires, and these wires are hidden behind the wall and they end here. And when you connect a device to these electrical outlets, the electrical device works and starts functioning. So, but where does the electricity behind the wall come from? It has to be from somewhere else. So it comes from electrical poles, and these electrical poles transfer electricity from electrical power station to our homes and all the buildings that we see. Good. We will see many different kinds of energy. One of the very important ways is electricity, and other forms of energy is magnetism. So magnetism is the energy that comes out of a magnet when it attracts something. Another form of energy or force is gravity. Gravity is a force that affects any and everything that has a mass. So let's compare both magnetism and gravity. And we start with gravity. So we said that gravity is a force that affects anything that has a mass, and it's affected by two factors. One, distance. Two is mass. So, what do we mean by affected by these two factors? Well, when something changes in the distance between the object and the planet, the gravity force changes. And the more distance between the object and the planet and the center of the Earth, the more distance, as the distance increases, the gravitational force of gravity decreases. But it's the opposite with mass. The more mass the object has, the more attracted it is to the center of the Earth. So the more gravity. So as the mass increases, gravity increases. And gravity is a pulling force only, meaning that it only pulls objects to the center of the Earth. But let's take a look at magnetism. Magnetism is a force, and this force is coming out of a magnet as it attracts objects that are made of iron, cobalt, or nickel, right? And magnets have something called a magnetic field around them, which is an area in which magnetism is working. The best way to see the magnetic field is by spreading some iron fillings, like a powder made of iron, around the magnet, and it makes this shape, and this is the magnetic field. Anything that's magnetic, when you put it here, is attracted to the magnet. When you put it out of the magnetic field, it's not attracted to the magnet. So, now what are the similarities between gravity and magnetism? Both of them are forces. Also, it's not necessary for objects to be in contact, to be affected by these forces, gravity and magnetism. But what are the differences between them? First, gravity attracts any object that have mass, and it also is a pulling force only, pulling downward. But magnetism attracts certain materials only, not everything like gravity. Certain materials, we said that they have to be made of iron, cobalt, nickel, or steel, which is another kind of iron. And magnetism is considered a pulling force or a pushing force when it's repelling another magnet. So it can be pulling or pushing. Good. In this lesson we talk more about magnets, and we make a very basic experiment talking about what's attracted to a magnet, what's not, and we said that it attracts objects that are made of iron or steel, nickel, and cobalt. Anything else is not attracted to the magnet. So anything else is non-magnetic, and iron, nickel, cobalt, and steel are magnetic materials. Very good. In this lesson, we're going to be talking about another form of energy, which is electricity. So how do we get electricity? We get it by generating it. And we generate electricity by the help of something called generators. Good. And generators are easily made by the help of a large magnet and some coiled wire. Well, what's the function of the generator? A generator, like almost any device, it changes one form of energy into another. So it converts mechanical energy or kinetic energy into electrical energy. So a generator converts mechanical or kinetic energy into electrical energy. Good. So generators exist in many places. In dams, converting the kinetic energy of water into electricity. In windmills, converting the kinetic energy of the wind into electricity. Or in fossil fuels burning stations, where the heat generates kinetic energy, and this is converted into electrical energy. Good. So let's try and make one ourselves. We call this the electromagnet. How does it work? Well, the flow of electricity in the battery and then the wires through the coiled wire. When you do this, and when you coil the wire around a metallic core made of iron, when the electricity moves, it generates or creates a magnetic field in this iron core. And then this magnetic field works as if you have created a magnet, and it attracts magnetic objects like iron nails. So this is how you can make a magnet, and we call this the electromagnet. Very good. Now, what are the components of a circuit? A circuit, first, is it's the path through which an electric current passes or moves. Electric current or electricity is the flow of electric charges along a path. This path we call the electric circuit. And the electric current is basically made up of something we call electrons. So let's see how. The electrons come out of the battery and they move in this circuit, in this path, and as they move, they make the device work, and then they go back and they keep moving like this. And this is a switch. The switch turns on and off the electricity, because when it's on, the electricity can't move. So the device is turned off, and when it's off, when it's closed, the circuit is closed, the device is turned on. So the main components of an electric circuit is a battery, a source of energy, a switch, wires, and a device. In this case, it's a lamp. Good. Now we need to know something very important about switches. Switches can be manual, like you turn them on and off, like any switch at home, or they can be automatic, like the switch in a thermostat in the refrigerator. You might hear the refrigerator sometimes being like making a sound as if it's working, and then it goes silent as if it's not working. This is the switch, automatic switch in the thermostat. And the thermostat controls and regulates the temperature of devices such as the refrigerator or the AC or anything that deals with temperature. Good. Now we're going to talk about something else, which is conductors and insulators. Electric conductors and electric insulators. So electric conductors are materials that allow electricity or electric current to pass through them easily. These can be metals, all metals, and water. On the other hand, insulators are materials that do not allow electricity to pass through them or to flow through them easily, such as plastic, rubber, air, cloth, paper, many other things that are electric insulators. So for safety, we coat our wires with plastic or rubber, because the wire has to be made of copper or anything that is an electrical conductor to transfer energy, the electricity from one place to another. But when you want to hold it, you have to be safe. So that's why we coat it with rubber or plastic to protect the person holding the device from an electric shock like this. So this is the end of lesson 3, and in the next video we are going to continue explaining this concept. If you have questions, as usual, you can always ask on the website, or you can always ask your teacher and try to solve as many questions as possible, and best of luck.